quality so that the other class can listen to it. Okay. When you first look at this, it's going to look like it's fixing to like talk above your head, look like it's going to be challenging. When I taught it with my other class, that's how it started, and then all of a sudden they're like, this is a piece of cake, I got this. So, lock in with me, and then you can take off and finish the back, okay? We are learning about the different types of numbers. If you recall, real numbers are the bulk name of every single number you can think of. Whether it's pretty or ugly, decimal, whole number, fraction, square root, 2, all of them. They're all real numbers because they really exist, right? There's another type of numbers that are called imaginary. Not kidding. They're literally called imaginary because they cross over into the imaginary world of numbers. You'll learn about those down the road. Right now, we're sticking to numbers that really exist. Great. Taking that concept, we have two types of real numbers. We have rational and irrational. You're going to hear me refer to these in the same context as the real world consists of rational people and irrational people. You're going to hear me say that a lot because it's really going to help you to know which word means which, okay? First of all, rational has the prefix ratio. Ratio is a fancy word for fraction. If I'm writing, you should be writing. So it is any number that can be written as a fraction. So it might already be a fraction. If it is, then it's definitely rational. It could be an integer. An integer is a pretty number. I'll say integers. An integer is a pretty number. For example, like the number 2. 2 is an integer. And you might say, okay, the question is, can I write it as a fraction? Well, what is 2 understood to be over? It's understood to be over 1. So because I can write it as a fraction, 2 over 1, it is considered rational. Or you can think of it as this.
Chase, what is that ringtone, bro? Oh gosh.
Hey, listen. Focus. I want you to also think. I want you to think rational sounds like fractional. You with me? Rational, fractional. Can I make it into a fraction?
Yes.
Integers? Yes. Another type of number that can be written as a fraction. A repeating decimal. Repeating. So for instance, I'm going to put a comma. 0.3 and then I'm putting a bar over the 3. That means 0.333333. Does anyone off the top of their head know what that is as a fraction? You should.
Anything.
It's 1/3. Go to your calculator and do 1 divided by 3. You're going to see that it's 0.3 repeated, which is your proof that a repeating decimal can be written as a fraction, and it's 1/3. There's another type of decimal that can be written as a fraction, and that's called a terminating decimal. Well, if something terminates, what does that mean? Stops. So it means it's a decimal that just stops. Doesn't matter if it's ugly, it just stops. Let's just make one up. 0.435. 0.435. Because it stops, then I can write it as a fraction. Now, technically, the way you would write it is you'd say 435 over, and then this is the thousandths place. You'd say over 1,000, and that's where you get the fraction. But we're not converting here. We're just checking yes or no, rational, irrational. I want you to think of rational as numbers that can be managed and dealt with to turn them into a fraction. How do you deal with rational people? You can manage them. If someone's being rational, they're level-headed, you can talk to them, you can carry on a conversation, right? What if they're being irrational? You're not going to be able to talk any sense into them. Let's talk about the numbers that are deemed irrational. That would be decimal. Now, don't write big here. You might want to wait and see it. Decimals that don't end and never have a pattern. Or you could say do not have a pattern. They don't end and they don't have a pattern. Meaning they don't repeat. So it's exactly like a person. They will not stop talking, and you cannot predict what's going to come out of their mouth because they're making note, like there's no pattern in their behavior or their logic. They are all over the place. You know what I mean? You cannot deal with a irrational person because they just keep talking, and you don't know what they're going to say. There's another type of number, and that is non-perfect radicals. Non-perfect. So the ones that will not break down any further. All right, so here we go. Let's do some examples. Negative 1.3472. I don't know the rest. ... What's the ... mean, y'all?
It keeps on going.
It means it keeps going, and you'll notice there's no pattern, there's no bar to let me know it's a pattern. Non-repeating, non-terminating, gonna keep going. That's irrational. That's like a person that just won't, shut up, right? They won't shut up, and they're not making any sense. You with me? There's another type of number. Square root 2. We've practiced with radicals enough to know that 2 does not break down. 2 is a number that got left in the radical all the time. That's because it's not pretty. Type square root 2 in your calculator. You're going to see the visual of why it's not pretty. Type square root 2. You're going to get a decimal that is ongoing and not pretty, no pattern. There's another type of number that we've really not talked about yet, and it is pi.
Oh, I remember pi.
Remember 3.1415? And then it keeps going, and there's no pattern. So yes, pi is irrational. Now, is it irrational to want pi? Like the food? No, not at all. But if it's a number with pi in it, now it's irrational. Okay, we need to talk about the operations with these types of numbers and what you're going to get, okay? I really want you to think of people. If you have a rational person in front of you, you can manage the conversation. But if you have an irrational person in front of you, you can't manage the conversation. So watch this. The sum or product of two rational numbers, what do you think it'll always be? Rational or irrational? Rational, because they're two rational people, right? You can put a giant R here, or you can make two R's. It's up to you. But two rational people can handle a conversation. Now, what if I'm finding the sum of rational and irrational?
It's going to be irrational. Because you can't talk to the irrational.
There you go. It is immediately going to be irrational because now you've got at least one person in the conversation who is not making sense. We're just going to put a big I here. So if you try to take rational numbers and add them to irrational numbers, it's going to stay irrational. You'll see what I mean by this in a minute. Now, what if I try to multiply? Now it says multiply. Now, why does it say non-zero? What happens if you multiply by 0?
It's just 0.
You just get 0. So that's why they're qualifying it by saying, hey, don't throw 0 in here. We're saying any number but 0. If you have a rational number other than 0 multiplied by an irrational number, once again, who's in the conversation? An irrational person. So the whole thing is going to be irrational.
So if it's irrational, anything is irrational.
Pretty much. Now be careful. This last one is tricky. Product of two irrational numbers. It can be irrational, or it actually could be rational. You might be thinking, how is that possible? Well, let's write this down and then I'll show you. You might be saying, how's that possible? Well, two irrational people. Clearly that conversation is going to be a hot mess, right? So it's very possible that conversation, they're just both yelling, they're both screaming, and it goes nowhere. You with me? So it stays irrational. All right, now come over here. You got two irrational people, and they both realize, hey, we're both yelling at each other. Let's simmer down and let's try and talk it out. Could that happen? Yeah, it happens all the time in my house. Like if we start raising our voice, every single person is totally allowed to say, can you stop yelling? Like, because it, yeah. So you could easily say, hey, I don't know if you realize this, we're both now yelling at each other. Like, this is not going well. Let's dial it down and let's try to actually talk it
Well,
out.
then it'd be awkward.
It's not awkward because that's a human, like, that's a human nature, you know. Your emotions are going high. All right. Now, so let me give you an actual math example. For instance, irrational. We said square root 2, right? What if I had square root 2 times, let's say, square root 3? Those are both irrational, correct? Because they don't break down. Now, this is good practice. Square root 2 times square root 3 is square root
4.
6. Does 6 break down?
Yeah. Oh, it doesn't. It's perfect. It's easy.
Chase, it's
It
not.
is a perfect. It's not a perfect.
1, 4, 9, 16.
6 is not in your list of perfect squares. So this would stay irrational. Now, let's look at when it's rational. Rational, the product, right? So we got square root 2 times square root 2. Ooh, you get square root 4, which is what, y'all? You get the square root of 4, which is actually just 2. So do you see how I started with two irrationals, but when I multiplied them, I came to a perfect, and now it comes out as a rational number. So that's an example of each. All right, that's it. Let's dive into the practice. Determine whether the following numbers are rational or irrational. Remember, if an irrational person, just one, all it takes is one irrational person's in the mix, the whole thing's irrational. Now, two irrational people, you actually have to check it. You could type it in your calculator and check it that way. So we got root 7 plus 8. What do you know about root 7?
Not perfect.
It's not perfect, so what's the problem?
It's irrational.
It's irrational. 8 doesn't even matter. The fact that
The one number.
the one in there is irrational.
Perfect square on the next one.
Now, this one, this is actually 4. So that's actually 4 times a fraction. What would I end up with? Rational or irrational?
Rational.
It's going to be rational. Because those are both rational numbers. 4 can be written over 1. 2/3 is already as a fraction. And if you don't believe me, you can type it in your calculator. Square root of 16 times 2/3, and you're going to see that it's a fraction. All right, what about this one?
Irrational.
This is irrational, and it's
Not
because of
repeating
this.
decimal.
Non-repeating,
Non-terminating.
non-terminating. So if you want to make that note, it's non-repeating, non-terminating. I spelled it wrong. Alright, square root 50 times square root 2. At quick glance, they both look irrational. Let's multiply them. You get square root, no, 50 times 2.
100.
100. What's the square root of 100?
10.
10. So is this rational or irrational? It's rational.
Just because it looks.
Right. You actually got two irrationals here. They could calm each other down and say, hey, we're screaming. We need to actually stop this. All right? What does sum mean? If I took 0.375, which is repeating, and added it to 8, they're not saying find it. They're saying would it be rational or irrational? Well, look at the type of numbers. This one was repeating, which means I can predict the behavior, right? So this is rational. This is a whole number. This is rational. So it would be rational. And then you can make your own little note of why. Now, pi over 2 and the product with root 16. What's product mean? Multiply. Do I really even need to think about this? No, why? What's in here? It's pi. The pi is throwing everything off. It makes it irrational because 16 is actually perfect, so that would come out as 4. But the pi, it doesn't matter what you do with that pi. It is going to be that, non-terminating, non-repeating decimal. Now, let me explain how to do the back, because when you first look at it, you're kind of like, what in the world? On the back, it's giving you the problem in the middle, and it's simply saying, check the box of what category. So, let me see the, oh shoot. I thought it would be on the back of that, but it's not. So it's asking you to check the box of which one it falls in. So you focus your attention here, and you just say to yourself, okay, is this rational or irrational? What do y'all think? It's irrational because of the root 5, right? So you come over here, some people shaded, some people just put a check mark. Some people put an X, that's fine. But that's how you answer, and then you move on. So now you direct your attention here. Another technique, y'all, is typing it in the calculator and looking at the answer.